Hello everybody, starting from this video, we're going to learn event, the probability for the event, and the basic relationship among event. So the reason we're going to learn basic relationship among event is because sometimes you might not need to spend time to identify each possible outcome for the experiment and then figure out their probability. Instead, you can use the basic relationship between events to figure out the probability. So therefore, in this part of the video, we're first going to focus on what is called event and how we identify the probability for the event. And then how can we use the relationship between events to assist us to figure out the probability in the efficient manner. So let's look at how do we define the event. So what is the event? So the event is a collection of the sample point. So it's a collection of the sample point. So I want to help you to understand what do we mean by event. So last time we talked about what is experiment. So for instance, if we roll the die once, and so our possible outcome would be 1, 2, 3, 4, 5, and 6, right? So those are the outcome for my possible for my experiment. So these are called sample point 1, 2, 3, 4, 5, and 6. So none of these is considered as an event. None of these are considered event. However, when can we define this is going to be an event? So let's see. If you we went to some when you go to casino, there are so many games. So let's invent a game. So you won't play the this game is called roll the dice. So if you will, you roll the die once. If you will receive the value larger than three, and then you win the game. Therefore, the event is called winning the game. So this is our event. So this is not one sample point. So this is called winning the game. So based on the rule of how we define winning, so you know that in order to win the game, you should get the number larger than 3. So then look at the definition. Event is a collection of the sample point. So therefore, you just need to find the sample point is experiment that is satisfy this event. So larger than 3 means if you get value 4, 5, and 6, and then you win the game. So therefore, this win is the event. Obviously, it is a collection of the sample point that is including 4, 5, and 6. Okay, so the reason we define this event as this way is because we ultimate goal is trying to figure out the probability for this event. So therefore, the probability of any event is equal to the sum of the probability of the sample point in the event. So what's the chance for us to win the game? So using the same example, okay, what's the chance to win in the game? So based on the definition, that is equal to the sum of the probability of the sample point in the event. So the chance for me to get 4 in one row, that would be 1/6, right? So if you don't remember how we get it, please watch the previous video when we talk about using the classical method to assign probability. And so the chance for me to get 5 is 1/6. The chance for me to get 6 is 1/6. So based on the definition of the probability of the event, I just need to add all of them together. So then I get 3/6 equal to 1/2 equal to 50%. Okay, so I have the 50% chance to win. If you don't use this method, if you think about, okay, I'm gonna win at least get 4, at least larger than 3, so which means half of the outcome means you win. So that's 50%, right? So this is how we build a connection between what we learned in the last video about sample point, and the events probability. So if we can identify all the sample point of the experiment and assign a probability to each, we can compute the probability of the event. So that's basically what we did in this example. So look at this case, broad investment again. So last time when we look at this case, is look at a multiplication accounting rule, multiple step accounting rule, and we figure out we have 8 possible outcomes, right? So let me go back to the 2 slides ahead of us. So in last video, we look at how you use the subjective method to assign a probability, right? So we have a 20% chance to for market oil gain 10,000, coal mining lose and earn 8,000. So one thing I want to point out is the expression of these parentheses. So the first number is the outcome, the the outcome from the coal mining, no, market oil. And the second outcome, that is the outcome from the coal mining. So in this case, market oil in 10,000, coal mining earn 8,000, and they say coal mining market oil earn 10,000, coal mining lose 2,000. So we totally have 8 possible outcomes. So this is the table we will use to assist us to figure out probability of the event. So let's look at the event. Well, we define it. So the event is called M. That is called a market oil profitable. So this market oil profitable. So what's the probability for market oil be profitable? Let's go back to look at this again. So look at this chart. Look at this chart. And so what's the chance for market oil making money? So remember, the first entry here is for market oil. Second entry here is for coal mining. So what's the chance for market oil market oil be profitable? And some students say, "Oh, I think it is 50%. Why? Because he or she believed that if you look at the first entry, we have the first 4 are positive. The rest of the 2 either break even or losing money. Therefore, 4 out of 8. Is that the right way to figure out probably for market oil be profitable? The answer is no. So that is the wrong way to figure it out, because when you're using that method, 4 out of 8, you believe for each outcome they're equally likely to happen. The fact is, it is not the case. So we have relatively higher chance to gain 10,000 for market oil and 10,000 at the same time coal mining earns 8,000. But we have very, very little chance to have market oil earn 10,000, coal mining lose 2,000. So they are actually is not equally likely to happen. Therefore, you cannot use 4 divided by 8. So the right method you should use is what we mentioned about the probability of the event. So first of all, you need to identify the possible outcome belong to the event. So obviously, the first 4 cases belong to market oil be profitable because the first number are all positive. And then based on the definition, the probability of the event equal to the probability for each outcome, right? So then you should use 20% plus 8% plus 16% plus 26%. So that is how you get the probability for market oil be profitable. So again, don't get confused between what you thought here, because each outcome they are not equally likely to happen. We actually have to use this subjective probability to figure out the probability for the event. So let's look at the answer together. So as we said, we identified these 4 possible sample points is belong to market oil be profitable, and then we find the corresponding probability and then add them together, and then we got 70%. So we have 70% chance that market oil be profitable. So how about another event? So this event is called coal mining be profitable. So coal mining be profitable. So coal mining be profitable. We are following the same steps. And so we go back to look at our Bradley oil investment outcomes. And then we're going to try to identify which outcome indicating the coal mining is making money. So obviously we're going to focus on the second entries. We identify this one, that one, this one, that one. Again, we actually have 4 experimental outcomes certify coal mining be profitable. And then after I identify these 4 outcomes, we're going to focus on their probability. And then adding these 4 probability together, the one I highlighted, and we'll be able to receive the coal mining be profitable. So let's look at our answer. So the 20% plus 16% plus 10% plus 2%, and we receive coal mining be profitable would be 48% chance. So we're actually going to use this number again. So therefore, you can write on a piece of paper about these 2 probability. Probability of M is 70%. Probability of C is 48%. Because later when we look at the relationship, we're actually going to using those probability again. Okay. So after we understand what is the event and how to identify the probability of the event, now we're going to look at the basic relationship between events. The reason is, like I mentioned before, sometimes you don't have to go back to look at each individual experiment outcome to figure out probability event. We actually can, based on the relationship of the events, to get the probability. So that's what we're going to focus on, 4 basic relationships. So the complement of event, the union of the 2 events, intersection of 2 events, and the mutually exclusive event. So 4 relationship. Knowing this 4 relationship will help us to get a relative probability very, very quickly. So let's look at the complement of an event first. So the complement of event A is defined to be the event consisting all sample points that are not in A. So I don't want you to memorize the definition. I want you to understand. So I used a chart to guide you to understand what is the complement of an event means. So also I want to emphasize notation. We are using AC and sometimes people using A bar. So it depends on which textbook you're using. Sometimes use AC. C stands for complement event. So M and MAC. So what's the relationship between A and A's complement event? So I'm using this Venn diagram to show you. So the circle area is indicating the event A. The whole square area is my total sample space. So the complement event of A is the area is not inside of the event A, but it's including the rest of the sample point. So let me give you an example. Let's see the whole sample. Let's just using the winning the gambling game. So we now roll the die once. The sample space will be 1, 2, 3, 4, 5, and 6, right? So this is my sample space. So last time we defined a win. So for winning the game is you get a number larger than 3. So therefore it's including 4, 5, and 6, right? 4, 5, 6. And then the complement event of win, which is win C, that will including the sample point that is not in the event at win. So then the complement event of win will be 1, 2, and 3, okay? So those are the complement events. So why we need to know the complement event? Because there is a nice relationship between event and the event's complement. So let's see probability of A, and we also know the probability of A's complement event. And the following condition always satisfied. Probability of the A plus the probability of A's complement event always equal to 1. So basically, if you know the probability A, you can very quickly to receive probability A's complement event. So you just use 1 minus the probability A, and you will be able to receive probability A's complement event. So that's what I said. Knowing the relationship, you don't have to go back to look at your sample point to figure out the probability. You can use the relationship to help you to figure out probability. So this is the first relationship. So this is pretty straightforward. And next one we're going to look at is the union of the 2 events. I hope you will remember that there is one thing I want you to remember, that is a notation, because no matter, as I mentioned before, there's some special mathematical notation. It's a universal language. No matter you talk to the people from which country, they will, although they don't know your language, if they see those symbols, they will know what does that mean. So that allow you to collaborate with the international talents, okay? So we're going to look at a union of the 2 events and what is the meaning of the union of the 2 events. So the union of the event A and B is the event containing all sample points that are in A or B or both. And so we're using this notation. It's like upside down U to denote the union of the 2 events. A union B. So I will use a Venn diagram to show you how do we identify the union of the 2 events. So the square still be my sample space. And then I will find 2 circles. One circle is used to denote event A. Another circle is used to denote event B. So the area inside the circle is event A, the sample point belonging to event A. And so this circle is the event belonging to the sample space belonging to event B. So when we're looking for the union of the 2 events, we are considering these 2 circles. Oh, sorry. So the whole shaded area, the gray area, so that is the union of the two events. So you can see the union of two events will be either belong to A or B or the common area, right? So this is the union of the two events. Usually, depends, but usually who are very familiar with the statistic, when you use the English word, we're using or. So we try to not use and. So A or B, A or B, okay? So this is the union of two events. Later I will introduce the probability, but not yet. We kind of identify the relationship first, okay? The union of the two events. So we are using the Brown investment example again, and we try to look at the union of the two events. So remember, this is the probability distribution, the probability we're going to use. So probability and possible outcome, okay? So here, what we try to look at is what is the probability of the union of the two events. So basically, we try to understand event M and event C. We try to find what is the probability for market oil or coal mining be profitable. So first, in this example, we are using the traditional method. That is, we're actually going to using the sample point, and then figure out sample point, which sample point will be belong to this event called the M union C, and then we add their probability together. So let's look at this outcome, this probability table. So either Bradley oil or coal mining be profitable. So what you are looking for is for these two entry, if we have one of the entry is positive, so that will be the one of the sample point we should consider. So obviously we have this one, both are positive. We also include this one because we have Bradley oil making money, Bradley oil making money, and also this one, both making money, and also this one, Bradley oil making money. And obviously this one, although the Bradley oil break even, the coal mine is making money. And not, we don't include this one because one is break even, another losing money, none of the outcome means making money. And then we should include this one because the coal mining is making money. We should not include the last one because both of them are losing money. So totally we have 1, 2, 3, 4, 5, 6 sample point belong to this union of the two events. So then we find the corresponding probability and then add them together, okay? So then I will show you the result. So the union of these two events. So we identify the 6 possible outcomes, and then we are including their probability and add them together, and then we will receive 82%. So 82% chance to have at least one stock is making money. So if you try to recall what we got in the previous video, so the probability of M is 70%, probability C is 48%. So the union of the two events is larger than both of the probability. It is pretty straightforward because in this union of the two events, we're looking for at least one of the stock making money. So at least one stock making money. So this union, the union of the probability of the union should be at least one. It should no smaller than the probability of M or probability of C. Okay, so this is how we calculate union of two events. Again, on the piece of paper, please write down this number. And so, because later when we are learning a law, we actually going to directly using this probability, and so you should know where this probability come from. So, probability M union C equal to 82%. Okay, probability M union C equal to 82%. So this is the second relationship. And the third relationship is called intersection of the two events. So the intersection of the event A and B is the set of all sample points that are in both A and B. So the notation we're using is the upside down view. Okay, upside down view is like arch A union B. So which means the A intersection B. Sorry. So when we look at A union B in the last video, so it's the upside down of this side. So you flipped it, and then this side becomes the intersection to event. So let's look at how we use a Venn diagram to indicate the intersection to event. Again, the square is indicating the sample space, and so we are using the first circle to indicate the event A and the second circle to indicate the event B. So when we look at the intersection to event, it cannot just belong to A or just belong to B. It has to belong to both A and B. Therefore, we find this common area. So this common area is our intersection of the two events. Okay, both of them, this sample point has to belong to both events. So that is called the intersection of the two events. So we're going to look at the Bradley investment example again. So in this case, we are looking at the both A, M, and C happening. So basically, what we try to look at here is look at M, intersection C. So we're using the English word and instead of all, okay? So M and C making money. So Market Oil and coal mining are all profitable. So let's go to look at this probability table. So in this situation, we're going to look at the both entry in the parentheses are positive because that's indicating both of them are making money at the same time. So that is the idea of the intersection. So obviously we have the first sample point, the third sample point, and then actually that's it because this one is break even and make money. So it's not satisfied both of the stock are making money. So we only have 2 sample points. So therefore we find the corresponding probability and add them together. That will give us both Market Oil and coal mining are profitable. So let's look at our answer. So these 2 sample points we found and finding corresponding probability and add them together, we got 36%. So this is the probability both stock are making money. Similarly, like last example, M union C. This is M intersect C, and I want you to write on a piece of paper for this value because the next part we're gonna look at is called the addition, the multiplication law. So you have to understand how to prove it. So we're actually going to using those numbers already calculated to prove that theory. So this is first theory we're going to look at is called addition law. Addition law. So addition law provide a way to compute the probability of the event A or B or both A and B occurring. So basically, this additional law allow us to calculate A union B without going back to look at your probability, sample points probability. Instead, we only need the probability of the 3 events, probability A, probability B, and probability A intersect B. And so if we know these 3 events probability, we don't need to go back to look at the sample points probability to figure out probability A union B. So before we look at the Bradley oil example, because we're actually using that example to prove the correction of this law, before we go there, I want to just use the Venn diagram to help you understand why this additional law should look like this way. So think about on the left-hand side, what we're looking for is A and B, right? So that's the whole area we're looking for. So if you think about, in order to get this shaded, red shaded area, seems like it's related to A and B. So A plus B, obviously, but why we need to minus A intersection B? So therefore, I want to use the diagram to help you to explain it, okay? So I'm using the red color to shade the area A, okay? So this is event A. And then I will using the blue for my event B. So you can see when we're using A plus B, just like what we see on the right hand side, A plus B, and you will notice that this center area, the common area actually are added twice, right? Because it's when we add A to B, the center area is added twice. However, if we look at the union of the 2 events, the common area only be counted once. Therefore, since we added it twice, we need to make sure we will reduce once. Therefore, we are A plus B, and then we're gonna minus this common area once because when you add A to B, this common area added twice. So that's why we need to minus. So this is called the addition law. So now we're going to use the Bradley investment case to prove the correction of this case. Therefore, remember in the previous video, we already figured out probability A union B. And we also have the probability A and probability B. And we just calculate probability A intersection B. We're going to using those values we calculated already to prove the correction of the addition law, okay? So the Bradley investment, let's see, we try to prove if probability M union C equal to probability M plus probability C minus probability A intersection C. So those are the probability we calculate. Those are the probability we calculated in previous examples. So now what we're gonna do is we're gonna using these two add together and minus this one. That's basically the right hand side of the addition law. And now we try to see what we get the answer we got from probably M union C. So this is the addition law on the right hand side. This is how it should look like. And then we receive 82%. So if you look at the note, I will ask you to write down because we did calculate before. So we can M union C, the probability is also 82%. So basically here I just use this example to prove the correction of the addition law. And so again, the reason we're using addition law is sometimes you just don't need to go back to look at your sample point to figure out probability of the event. Actually, you can use this kind of relationship to figure out the probability of the event. So the fourth relationship we're going to look at here is called a mutually exclusive event. So mutually exclusive event. So the two events are said to be mutually exclusive if the event have no sample point in common. So two events are mutually exclusive if when one event occurs, the other cannot occur. So basically, if we use a Venn diagram, so that's how it looks like. There is no common area. So in the real world, if you try to identify the two events that are mutually exclusive, you just ask yourself, if event A happened, well, that means the event B cannot happen. So if the answer is yes, so the two events will become mutually exclusive event. If the answer is no, and then that will not be considered as a mutually exclusive event. So for instance, and every morning you woke up and you either stay at home and go to school. So that will be mutually exclusive event because you cannot stay at home at the same time you go to your classroom, right? Except now we have the pandemic, you can learn class in your home. It's a different story. But before the pandemic, you either go to school or stay at home. So that become a mutually exclusive event. So event A happen, event B cannot happen. So why we're introducing this mutually exclusive event? Because if we can prove the two events are mutually exclusive, so our addition law will become the simplified addition. The reason is because the originally we need to minus P interceptor B, but as we just seen in the Venn diagram, if they are mutually exclusive, the intersection part becomes 0. So therefore we can ignore this P probably A intersection B. So if you know the two events they are mutually exclusive, and so what you need to do is probably A plus probably B. That will give you the probably A union B. Okay, so this is the mutually exclusive event. So in our next video, we're going to look at a conditional probability and addition law. And then we're going to focus on the Bayesian theory. So that is the last part of this chapter. So make sure you spend a lot of time. And also I will show you many examples in terms of how to use in the Bayesian theory to find the probability.